Now let's see the reduction formula for integral 0 to pi by 2 sine power nx dx. That is, if I wanted to find integral of 0 to pi by 2 of sine power nx dx, where n belongs to positive integers and at the most n is greater than or equal to 2, then we have this equal n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4, 3 by 4, 1 by 2 times pi by 2 if n is even. Then I have this equal to this, and this will be n minus 1 by n times n minus 3 by n minus 2 times n minus 5 if n is odd, is how we identify the two cases for finding integral 0 to pi by 2 sine power nx dx. If n is even, it is this times this times this, where the last term is pi by 2. If n is odd, then we have the same terms reduced to the last terms as 4 by 5 into 2 by 3 times 1. The cases of n even and n odd derives two respective formulae for integral 0 to pi by 2 sine power nx cos power nx sine power nx dx. Now, as we know that integral 0 to a f of x dx is integral 0 to a f of a minus x dx, and using this property, if I wanted to find integral 0 to pi by 2 of cos power nx dx, using this formula, this reduces to integral 0 to pi by 2 of f of a minus x, where a is pi by 2. So this reduces this. So the right hand side is substituted with the left hand side and I get this. And as I know that cos 90 minus theta is sine theta, and therefore this reduces to 0 to pi by 2 of sine power nx dx. Therefore, integral of 0 to pi by 2 cos power nx dx will be integral 0 to pi by 2 of sine power nx dx. Both are equal. That's how we understand the two formulae connected. Integral 0 to pi by 2 cos power nx dx is equal to integral 0 to pi by 2 sine power nx dx. Therefore, since integral 0 to pi by 2 of cos power nx dx is equal to integral 0 to pi by 2 of sine power nx dx, we have the same formula which we have derived for sine as that for cos. That is, if n is even and if n is odd, where n belongs to z plus and n is at the most greater than or equal to 2, then we have this formula which is greater than 2. Then we have for n even, the formula is n minus 3 by n, so n minus 1 by n and n minus 3 by n minus 2, so on and so forth till 1 by 2 times pi by 2 if n is even, and this will be n minus 1 by n minus 3 by n minus 2 times 2 by 3 if n is odd. Therefore, integral of this is equal to integral of this, which is this when n is even and this when n is odd. Now let's see the related problems. So in case of this, say for example, I have an example problem cos 7x dx. So the question is to find this. Then clearly when I compare this with integral 0 to pi by 2 cos power nx dx, then I see that my n is 7, which is odd, and therefore taking the odd case of integral 0 to pi by 2 of cos power nx dx, which is n minus 1 by n minus 3 by n minus 2 of this is what we get in case of the reduction. Therefore, integral 0 to pi by 2 cos power 7x dx with n equal to 7 substituted here gives 7 minus 1, which is 6 by 7, and we observe that each of the terms of the numerator and denominator gets reduced by 2 units. So 6 by 7, next is 4 by 5, next is 2 by 3, which is the last term, and hence we halt here. And therefore integral of this is identified as this times this times this. When I cancel 3 1s, 3 2s, then I get 4 2s are 8, 8 2s 16, 7 5s 35. Therefore, integral 0 to pi by 2 cos power 7x dx will be equal to 0 to pi by 2 sin power 7x dx, which is 16 by 35, is how we identify integral of this equals 16 over 35. And even integral sin power 7x also is this, because they are equal. Now let's see the evaluation of integral with combination of m and n. That is, evaluation of integral 0 to pi by 2 sin power mx cos power nx dx. So let's see how we can evaluate this integral using the formulae. So there are different cases through which I can evaluate each of the integral. Integral 0 to pi by 2 has 4 cases. Totally 5 cases, 1 2 3 4 5, where I have 1 2 3 4 and 5. So as we see each of the cases, let's come initially with n even and n odd. That is, if n is equal to 1, and then I take here with the condition m is equal to 1, then I have, let's see what happens for n equal to 1. Integral 0 to pi by 2 sin power mx cos power nx when n is equal to 1 is 1 by m plus 1, and here this is 1 by n plus 1, which we get by substitution method. Now similarly, if I take n not equal to 1 is odd, then let's see what will be the solution of this. If n not equal to 1 is odd, then I have this as n minus 1 by m plus n, and next the third case is n is even and m is even, and next is n is even and m not equal to 1 is odd. So these are the different cases 1, 2, 3, 4 and 5 through which we derive. For n equal to 1, the answer for this integral is 1 by m plus 1, and for m equal to 1, the answer is 1 by m plus 1, and for n which is odd or not equal to 1 is this minus 2, and so on and so forth by 2 by m plus 3, and then we get this to be 1 by m plus 1 is what we get in the final two values. Next is if m is odd, then in this case I have this as n minus 1 by m plus n, n minus 3 by m plus n minus 2, so on and so forth by 1 by m plus 2. Now therefore, in case of n is even and m is even, I have n minus 1 by m plus n, n minus 3 by n plus n minus 2, and so on and so forth till 1 by m plus 2, but continued m is even, therefore I have m minus 1 by n, and then next is m minus 3 by m minus 2 of 1 by 2 and pi by 2. Now clearly we see that this is the even condition of the previous session which we have seen in integral sine power nx or integral sine power cos or integral cos power nx with limit 0 to pi by 2. Now similarly this with m being odd comes as m minus 1 by m times m minus 3 by m minus 2, so on and so forth till 2 by 3 is what we get in that case. So we see that there are totally 5 cases of case 1, case 2, case 3, case 4 and case 5. With each of the case 1 the answer is this, and case 2 the answer is this, and each of the answers are with their respective m and n. But with the case 2 it is very important to note that if n is odd, this answer is irrespective of m, because for odd case m can be either even or odd. It doesn't affect, the formula is the same for m being either even or odd, but n has to be odd and not equal to 1 is a special case in case of all the 5 cases considered out here. Now let's see some related problems connected with this. So for this, let's take an example problem. Say I want to evaluate integral 0 to pi by 2 sine power 6x cos power 4x dx, and as I compare this with sine power mx cos power nx dx, I clearly see that my m is 6 and n is 4, and both are even, and hence we have both m is even and n is even, which is the third case, and let's see how we can expand using the case 3 of the formula. Integral 0 to pi by 2 . So in order to evaluate integral 0 to pi by 2 sine power 6x cos power 4x dx with each of the even cases, then I have this with the formula m minus 1 by m plus n, n minus 1 by n plus n, and next is n minus 3 by n plus n minus 2, and so on and so forth till the last term which I get, and then taking the next pair starting with n even, I get m minus 1 by n and m minus 3 by m minus 2, so on and so forth till 1 by 2 and pi by 2 is what we get for the second set of numbers. So using this, it's easy to simplify when we just directly follow from the first term with each numerator and denominator reduced by 2 terms. Therefore, as I see here, my n, which is 4, is 4 minus 1, which is 3, and m plus 1, which is 10. Therefore, once the first value is evaluated as 3 by 10, substituting n and m respectively, then the next term is 2 terms short of 3 is 1, and the next term of 10 is 2 terms short of 10, which is 8. And then finally, you cannot proceed further because this cannot be reduced 2 terms shorter, which goes into the negative side of the numbers. So we halt here and then we go to m minus 1 by m. Similarly, m is 6. So using the formula 6 minus 1 by 6 is what we get in the initial term. And I see that each term is reduced by 2 units. Therefore, each of numerator is reduced by 2 units here, and next again the 2 units here, and of course pi by 2, which comes because it's an even case, is how consecutively each of the numerators and denominators are reduced by 2 units each time we proceed further. This on simplification gives us the whole of 3 1s, 3 2s, 5 1s, 5 2s is what we get. Therefore, this on simplification gives 3 pi by 4 2s are 8, 8 2s are 16, 16 2s 32, 32 2s 64 times 8, 6 8s 48, 512. Therefore, integral of 0 to pi by 2 sine power 6x cos power 4x dx is 3 pi by 512 is how we identify the integration.